Okay. I think we can just kick things off so we don't keep you waiting and then more people can just join over time. So, hi everyone, welcome. Thank you so much for joining. We have an amazing session for you guys today, and it's a session that I'm also looking to learn a lot from. So I'm also going to be paying rapt attention. I feel like you all already know me at this point. I'm Toyi Bat, and I'm going to be your host for today. And we have our guest speaker here, Manny. If at any point you guys can't hear me or anything, please let me know so that I just fix whatever issue is happening. But yeah, we're just going to keep things off now. So yeah, I'm going to start by introducing our guest speaker to you guys, and then he can move on to giving his presentation. So Manny is a technical writer by day and an engineer by night, and he's also a father everywhere in between. Manny wears many figurative hats. He is passionate about intuitive and scalable developer experiences, and he likes diving into the deep end as the zero user. He also has a few things that
Oh, I think we lost her. Well, oh, here she is. We cannot hear you.
uh-oh, what's going on?
There we go.
Oh
We
yeah,
got
she's
you.
back.
Sorry.
Apologies. Yeah, we can hear you, Toy Bath now.
Yeah, sorry about that. Sorry, where did you lose me? I didn't even realize I was kicked off the call.
It's okay.
Okay.
You dropped at, there are a few things to keep me busy.
Oh yeah, thank you. So as I was saying, there are a few things that keeps Manny busy, and the first is that he's the head of docs and user experience and workflow at Skyflow, a data privacy vault company. Another thing that keeps him busy is developing docs as tests, a tool agnostic strategy for keeping docs and their products in sync by using doc content as product tests. He also authored Docs as Tests, a strategy for resilient technical documentation. Something else that keeps Manny busy is developing and maintaining Doc Detective, and this is an open source doc testing framework. And the final thing that keeps him busy is AI development and experimentation. Ah,
Oh,
sorry about that. I have no idea what's happening today. But yeah, Manny is always looking for collaborators on his projects and he loves chatting with folks. So don't hesitate to reach out. So yeah, thank you so much, Manny, and welcome.
thank you.
Really
Thank you.
excited to listen.
Yeah,
Really
it's my
excited
pleasure
to
being
learn
here.
from
Thank you for
you
having me.
today. Yeah. Okay.
Um,
So I think
oh,
you can kick things off and I can just hand the mic over to you.
I'm sorry. I couldn't quite hear. Well, from here, thank you very much for having me. I'm always happy to chat about the stuff that I'm working on, especially with fellow technical communicators. This is, sharing knowledge is another thing that I am passionate about. So let me share my screen and let, I'll get to talking. So, welcome everybody. As you know from that fantastic introduction, I'm Manny, and today we are going to explore the exciting potential, at least exciting to me, potential of making your docs testable. And I promise this is really exciting, and there is a lot to this idea as you dig into it. Um, as was mentioned, I'm Manny. I'm head of documentation at Skyflow. That means that I own everything that involves words that is not marketing, whether that's UI strings, external documentation, internal documentation, error strings, error codes, API surface area, you name it, I do it. Then yes, I have. codified docs as tests and written about it extensively. There's more to come, but I also created and actively maintain Doc Detective, a tool to help authors test their content. Um, Now, I could talk about docs as tests for hours. I literally wrote the book about it, but I don't have that much time today. So I'm going to cover the strategy in what detail I can. And if all goes well, there will be cats. First, let's start by exploring the fundamental problem that docs as tests aims to solve. If there's one thing I've learned in technical writing, it's that something always breaks. You create perfect documentation for a new feature. Your procedure says when you're ready to get started, click begin, and you include a nice screenshot that includes the begin button. The documentation is published, and all is right in the world. Then, 3 months later, you hear from customer support that a user reported that the docs were wrong. Wrong, you say. Then you look, and somehow that begin button is now labeled start. The UI changed, but the documentation didn't. This seemingly minor change creates major trust issues with users, and it happens constantly across our industry. The consequences of incorrect documentation are far reaching. When users encounter incorrect docs, they contact customer support, which increases support costs. They lose trust in your documentation and, by extension, your product. For prospects in pre-sales pipelines, documentation issues may lead them to choose a competitor. Existing customers might start looking for alternatives. How many issues have these customers encountered before this docs bug was the final straw? There's also the legal angle. Many contracts specify that products work, quote, as documented, which creates potential liability. Rare, but true. Remember, we don't write docs to write docs. We write docs because they're critical to every stage of user success. So, how have we traditionally tackled this problem? The historical way of documentation testing is mostly manual. Somebody sits down and steps through the procedures, flagging issues as they arise. Some teams perform freshness testing at regular intervals. Others leverage QA teams to validate documentation, but the reality is that technical writing teams are chronically understaffed and under-resourced. We rarely have time for comprehensive manual testing, and guess what? Our QA teams are in the same boat. Too often, testing is performed by users in production. They're the ones discovering our documentation gaps. It's like I say, if you don't test your docs, your users will. And that's not a position any of us want to be in. Now, with the problem defined, let's explore the solution, docs as tests. Docs as tests is a tool agnostic strategy that keeps your documentation in sync with your product. At its core, it's about treating documentation as testable assertions or statements about how your product works. When I first developed this approach, I was drawn to how engineers use automated testing to maintain code quality. I wondered, where's the automated testing for documentation? When engineers didn't have an answer, I created one. Docs as tests brings testing practices from the engineering world into documentation, but tailored to our specific needs as content creators. Now, let's put this a bit in context. There are a lot of docs ases out there. So let's talk about what each of them is and how docs as tests fits in. So docs as code, which is one of the most well-known docs as approaches, applies engineering infrastructure and continuous integration, continuous development practices into documentation. That's why a lot of folks use GitHub and CI/CD for build processes, Stockisaurus as and other tools as static site generators. That's all borrowed engineering practice and infrastructure applied to documentation. Docs as product treats documentation as a product in and of itself rather than a byproduct of something else. Docs as ecosystem incorporates community management principles, feedback, and considerations into documentation. Docs observability brings telemetry and monitoring from engineering into documentation, and Docs as tests adds automated testing and behavior validation to documentation. Together, these strategies represent our field learning from adjacent areas to improve documentation quality and reliability overall. Now, let's clarify exactly what Docs as tests is. First, it's UX validation between documentation and product, ensuring that what we tell users matches what they experience. It's automated freshness checking that verifies that documentation is accurate, but without requiring manual effort. It implements a zero trust relationship between docs and product, where we verify through testing rather than assuming alignment. It treats procedures as testable assertions about how our products work. It transforms docs into the kind of tests that engineering teams find the hardest, end-to-end tests. And most importantly, it's a comprehensive approach to building and maintaining user trust through reliably accurate documentation. But it's equally important to understand what Docs' tests isn't. It is not linting. It is not style checking. It is not format checking. It is not link checking. These are all valuable documentation practices with excellent existing tools, but they address different concerns. While these approaches check for formatting, check for structure, check for implementation of the documentation itself, Docs as tests validates that the content is accurate and in alignment with product behavior. These approaches are complementary. We should be using them all for comprehensive documentation quality improvements. Now, let's explore the 5 fundamental principles that define docs as tests. At a high level, and we'll get into each of these in more detail. Docs are tests. Tests are repeatable. Doc-based tests don't replace engineering tests, they complement them. Your implementation has to be resilient for your tests to be resilient and reliable, and the tests run against the product itself. Let's unpack each of those. The first core tenet is simple but powerful. Docs are tests. Every procedure, every screenshot, every API reference in your documentation makes testable assertions about how your product works. If you write, click the submit button to save your changes, we are asserting that there's a button that's labeled submit and that clicking it saves changes. These assertions are inherently testable. And remember, if you don't run these tests yourself, your users will do it for you, often at the worst time possible in my experience. The second tenet, tests run against the product. Doc-based tests must validate the actual user experience, not mocks or not simulations, well, unless those are your product. If your documentation describes a web interface, test against the web interface. If it documents an API, test against the API. This ensures that your tests catch the same issues that users would encounter. And when possible, test in production-like environments that mirrors exactly what the users will experience at the time of testing. They'll always do it in controlled ways with test account, fake data, that sort of thing. Now, the third tenet is that tests are repeatable. One-time validation doesn't help when products change constantly. Your doc tests should be resilient enough to run repeatedly after product releases, during development, and on regular schedules whenever you need them. Ongoing validation makes sure that documentation stays accurate as products evolve. Remember this truth. If a test isn't resilient enough to be repeated, it's not resilient enough to be trusted. Flaky tests that work occasionally but fail unexpectedly undermine confidence in your testing approach. And Dox's tests is all about trust and confidence in the accuracy of your content. The fourth tenet focuses on resilient implementation. Documentation receives contributions from many sources: writers, developers, project managers, subject matter experts, the list goes on. Your testing approach should accommodate this variety of contributors. Design tests that are adaptable to expected changes in both documentation and product. The more resilient your implementation, the more sustainable your testing practice becomes. This might mean using text-based selectors that update automatically when UI text changes, or writing tests that validate behavior patterns rather than specific implementations. As for the fifth and final tenet, doc-based tests complement engineering tests. Doc tests don't replace engineering tests. They serve a very different purpose. Engineering tests verify code functionality and implementation details. Doc tests verify that what we tell users about a product is accurate. Both are necessary for a comprehensive testing strategy. Engineers shouldn't stop writing tests because writers are testing, and writers shouldn't assume engineering tests validate documentation accuracy. We're comparing apples to oranges. These testing approaches work together, each addressing different quality aspects. But now that we understand the core principles, let's explore how to apply them to different types of documentation. And I think the best way of doing that is with a demo. So I know this is streaming to YouTube, and I'm about to play a YouTube video, but this is really the best way of going about doing it. So I'm going to attempt playing this. If you can't hear, tell me, and I will try to narrate over this, but there's already an audio track to it. Here we go. All right. Today, I'm going to show you how to test various product interfaces with Docs as Tests tooling. I'm specifically going to show you with Doc Detective because I can show you a lot of different stuff pretty quickly. Let's get to it. Here, we have a markdown procedure for using a locally hosted graphical user interface, or GUI. The procedure is pretty simple. Open up the GUI, find some text on screen, and then click option 1. There's also a broken image reference because proof.png doesn't exist yet. Let's fix that. I'm going to run Doc Detective against local GUI.md, what we're looking at right here. And what's going to happen is the tool is going to look at the markdown file and look at the syntax of the markdown to determine all the different things it should do, like navigating to that URL, finding that heading, and clicking option 1, then taking the screenshot. Let's refresh the preview of the markdown right now so we can see the final result. Boom, there's the screenshot. It didn't exist before, it does now. And not only that, but we can look back at the test results and see that each and every step passed with details about the execution of that test. But Manny, you say, this is a highly synthetic example. What about something closer to a typical procedure? I'm glad you asked. Let's search for some cats. I like cats. I want to help people get more information about cats, maybe look at some pretty kitty pictures, because cats make the internet go round. So here, this procedure is saying go to DuckDuckGo, enter American Shorthair Kittens, press enter, and save a screenshot of the results. Here, because I'm on spotty internet right now, I'm hard coding a 10-second wait just to make sure that I get all of those cat pictures for this demo. Let's run it. And note that we already have a screenshot this time around. Now, just like last time, the tool is going to look at the markdown file, extract all of the tests possible based on the detected syntax, navigate through, and would you look at that, all sorts of cats. I love it. It makes me feel so warm and fuzzy, and it's going to capture a screenshot once it's done with the wait, and yay, it's done. But oh no, this failed. Well, guess what? It was supposed to. Every other test passed. We watched it pass. It did everything it was supposed to. It even saved the screenshot, but it did a comparison between the newly captured screenshot and the existing one to see if there were visual differences. This is called visual regression testing. And it determined that there was a 23.19% difference between the screenshots. This is indicative of when a UI changes and the existing screenshots are out of date. This tool let us not only check if the existing screenshot was still accurate, but when it wasn't, it captured a new one. So we didn't have to go back and do it manually ourselves. Now, there are other ways to go about this sort of testing. If you don't want to detect tests, you can specify them in line. So here we want to say, okay, let's check this link. Great, let's check this URL to make sure that they're valid and accurate and they resolve correctly. Here we want to go to this URL, spinning up a web browser and navigating there. And while we're there, we're going to find an element that matches this text and then take a screenshot just like we have before. I'm not going to run this test. You've already seen what that looks like. I just wanted to give you an idea of what inline tests can do and how they look. Also, you can mix inline and detected tests, like we just saw with the kitten search and that hard-coded 10-second wait. Now, this is a lot of GUIs, user interfaces or graphical interfaces, but there are other interfaces like APIs. We can do API testing, where here we're going to load some secrets from into environment variables from file. We're going to load user and job secrets on the fly at runtime, and we're going to expect that the API request to this locally hosted server is going to return name of John Doe and job of software engineer. But then for our next test, we're going to send a request, so first and last name, George Bluth with an ID 1. We're going to make sure that it echoes back the first and last name, but we're going to capture the ID field of the response and set that to an ID variable. This is similar to if you needed to get an ID of a resource for a REST API, or if you needed to do authentication, such as generating a bearer token, you can capture that value and use it in subsequent steps to authenticate your API. Here, we're going to use the ID value in the URL, but it's the same idea. Let's see how this looks. So HTTP spec YAML, passing it into Doc Detective. It's going to take a moment. Oh, hey, that moment was fast. Let's look at the results. So we can see that we successfully set the variables. We can see that the first request did indeed return John Doe and software engineer loaded from environment variables. Here for the second request, we see that it indeed returned George Bluth and that we captured the ID we set the ID variable from the response body value. And that where it was $ID1, it substituted it on the fly to the ID value of 1. Also, we saved this response to a path, just like the visual regression testing that we did with the kitten images. We can do response regression testing from the API so that if there are unexpected changes to the API's response, that could be indicative of either stale documentation that wasn't updated correctly or of an unexpected product change. In either case, there's something worth investigating, and this tooling can help you do it proactively. Now, in addition to GUIs and APIs, you can also test CLIs or shell commands, whether that's Bash or PowerShell or whatever it is. Here, we're going to run a Docker command, Docker's hello world, and we're going to make sure that it outputs the text hello from Docker. And we're going to run that right here, Docker hello, and it's only going to take a moment, and boom, it's done. Let's take a look at the result. Here, we can see that indeed it had an exit code of 0, which means that it completed successfully, and the response included hello from Docker. So we consider that a successful outcome. We've tested GUIs, APIs, and CLIs right here in just these few minutes. There is so much more that you can do. You can test your SDKs, you can test your code, inline code blocks in Markdown or whatever, AsciiDoc or RST or anything else. There is so much that we can do. This is just the tip of the iceberg. That was a lot. Let's unpack it a little bit. You saw that we tested GUIs, or graphical user interfaces, and that means that we're validating procedures through automated interactions, following navigation paths, submitting forms, verifying that outcomes match what our documentation promises. Docker actually does this today, testing their web-based UIs with Playwright. One of the most powerful aspects of this is automatically capturing and verifying screenshots like you saw in the demo. Instead of manually updating screenshots every time an interface changes, your tests can automatically capture the current screens and then alert you to changes or update images automatically. This can dramatically reduce the maintenance burden of visual documentation. But APIs might be the most testable part of your product. Unlike GUIs, which require complex automations to simulate clicks, drag and drop elements, type in keys, APIs communicate through structured requests and responses that are relatively straightforward to verify. Testing API documentation involves three main approaches. Contract testing verifies that your API behavior matches its formal definition. Workflow testing validates that sequences of API calls accomplish specific tasks. And request response validation ensures that your example requests produce the expected responses. Together, these approaches validate that your API documentation remains accurate, remains reliable. There are a lot of different definitions out there for working with APIs, and API definitions play a critical role in documentation testing. Formats exist like OpenAPI for REST APIs, which, by the way, they just came out with OpenAPI version 3.2, I believe last week, as of time of this recording. Async API exists for event-driven systems. GraphQL is around for user-defined requests, though it still operates over HTTP. Aurazzo exists for workflow definitions based on OpenAPI, and there's been talk about it supporting async API in the future. All of these and even more, like Kafka for event descriptions, provide machine-readable descriptions of your APIs. And these definitions serve double duty as both documentation and test specifications. By testing against these definitions, you verify that your API's implementation matches its documentation. And these descriptions create a single source of truth that drives both your reference documentation and your testing. Tools like Postman, Bruno, Respect, Speakeasy, and Microx can use these definitions to automatically validate your APIs against their documented behavior. That's contract testing. Oftentimes, contract testing is outside the scope of what technical writers can do on our own. But when we pair with our QA teams and or engineering teams, it becomes entirely possible to run comprehensive contract tests for each of our APIs. Now, testing commands and code. They're both very impactful parts of technical communication. They're oftentimes also the first entry point that users have into our products. When a command fails or a code snippet throws an unexpected error, we lose user trust and we waste users' time. Testing code in documentation means verifying that code examples run as written and that commands execute successfully. This validation is vital because code examples are often the first things users try when they're getting started with a product. If those user experiences are negative because examples don't work, users might abandon your product entirely. AWS, Raspberry Pi, MongoDB, they and many other folks have adopted this style of testing their docs content. Now, with the strategy overall and the approaches understood, let's explore how to implement docs as tests in your organization. Selecting the right testing tools depends heavily on your team's technical expertise. There's one thing I'm going to emphasize very strongly. There is no best tool. There is no best tool. And I'm saying that as a guy who's written a tool to do this. There is only the tool that is best for your team and your requirements. Now, for novice users wanting minimal barriers to entry, options are unfortunately limited. There's a gap in the market for truly beginner-friendly documentation testing tools. We're early days in this, so there isn't a lot there. I'm hoping eventually Doc Detective can help fill that gap. But at the intermediate level, today, tools like Doc Detective, Microsoft's Innovation Engine, and RunMe offer documentation-focused testing capabilities with manageable learning curves. For teams with full-on engineering skills, advanced tools like Playwright, Cypress, and Selenium provide really powerful capabilities for GUI testing, while Postman and Bruno excel at API testing. The key is to select the tools that match your team's technical capabilities while enabling effective documentation validation. Remember, your team isn't just you. It's not just your engineers. It's whoever needs to maintain the testing infrastructure for all of your contributors. Now, let's look at how this works in practice. Here is a simple procedure, a little bit of documentation in Markdown. It instructs the user to search for kittens on DuckDuckGo. This documentation makes several testable assertions. That DuckDuckGo is accessible in the first place, you can load it in a web browser, that it has a search bar, that typing Maine Coon kittens and pressing enter will perform a search, and that the results will look like the screenshot we've already captured. Each of these assertions can be tested programmatically to verify the documentation's accuracy. This is an example of a standalone test, meaning this isn't actually rooted in the documentation. This test lives on its own, but it replicates the procedure we were just looking at. If you're familiar with Cypress or JavaScript, you might be able to parse out that it's testing that the navigation and search and screenshot work well, but then we've got cy.visit, checks some stuff in the URL, does a whole bunch of processing. This is engineering level work, but this is what it looks like to test the procedure with Cypress. Playwright, it's a little bigger. It's a little more colorful, thanks to the syntax highlighting, but it's effectively the same thing. We're still using a test that is independent of the documentation itself that replicates the procedure. Still useful, can still validate that the procedure works as written, but this is what it looks like in Playwright. In Doc Detective, here's the same procedure, and it follows the same test that a user is asked to do. It navigates, it inputs a search, types, presses enter, captures the screenshot. This test validates every part of our documentation. As you can see, this is written in YAML. It's just a different interface. It doesn't require you to know how to code, but it does require that you get familiar with Doc Detective syntax. But even still, if for any of these tests, if DuckDuckGo's search interface changes, perhaps the selector for the search box updates, the test would fail and alerts us that our documentation needs updating. Uh, or it tells us that our test was fragile in the first place and that the test needs updating. That's the difficulty with standalone tests. Similarly, though, if the search results format changes significantly, then the screenshot comparison could identify the discrepancy. But if we don't want to do standalone tests, if we don't want to write tests for our docs, instead we want to use our docs as the tests themselves, then we get into inline testing, embedding the tests directly within documentation using inline comments. This method of defining tests keeps tests physically close to the content that they validate, and that makes it easier to update both simultaneously. In this example, each step in the procedure has a corresponding test directive in a comment. So when you update the procedure, you naturally see and can update the associated test. Tools like Doc Detective can parse these inline tests and execute them, providing a pretty tight coupling between documentation and the validation itself. And this approach is particularly valuable for maintaining test accuracy as documentation evolves. But this can be your test. Like you saw in the demo, some tools can automatically detect the markup of source content and generate tests from it. If there are steps that aren't easily detected, you might mix inline tests with detected tests to fill in the gaps. But either way, you can make this work. And if the tooling you choose supports the syntax that you write your content in or publish your content in, then detected tests can be a way to substantially lighten the load of test maintenance. And instead of having your documentation and your product, and also having a layer of tests between them, the documentation itself becomes the tests that you run against the product. So you don't have to maintain a separate artifact to enable testing. How do you do all of this? Starting with docs as tests doesn't require a massive all at once implementation. Begin by choosing tooling that matches your team's skills and your documentation needs. Run a trial with a small but important procedure. Pick something meaningful from your documentation's happy path that users rely on. Automate and validate just that procedure to prove out the concept. Once you're successful, then you can expand your scope by adding more tests for critical documentation, gradually increasing coverage over time. As you build momentum, you'll see some real benefits, what I have as profit up here on the slide, but I mean that quite literally. Tested documentation reduces support costs, increases user retention, and prevents the kinds of documentation failures that can lead to lost sales or even litigation. And as your testing practice matures, consider validating documentation across different environments. A good starting point is testing production documentation after every release. This catches misalignment between docs and the released product. Better yet, You can test against staging environments with every code push. That way, you can catch potential issues before they're ever published to users, before a user can ever run into an issue. Plus, you can still test against production after release in case a change was cherry-picked and it made it into production but slipped through without going through staging. It's unfortunate, but it happens. The most comprehensive approaches add testing in development environments with every merge if your team has that sort of an infrastructure set up. But this allows you to identify documentation impacts from code changes at the earliest possible stage. You still get to check against staging, you still get to check against production, but this multi-environment approach creates layers of protection, helping your documentation remain accurate throughout the entirety of the software development lifecycle. But with all this power comes responsibility. Remember that test actions are real actions. When your test creates a user account, when your test deletes data, it's actually happening in the system. Always clean up the resources your tests create to avoid accumulating test data or hitting resource limits. You don't want to be the reason why your team's AWS bill is high. Never test against real user data. Never test against real user data. Always use dedicated test accounts, use synthetic data, and wherever possible, set up proper test environments with guardrails to prevent tests from affecting production systems unintentionally. If you have multiple production servers deployed, see if there's one that's available for you to test on that won't impact your live customers. These precautions help your testing practice remain sustainable and not create new problems while solving existing ones. Now, let's consider the broader impact and the potential of docs as tests. The true value of docs as tests goes beyond catching errors. It transforms documentation from a potential liability to a verified asset. When you automate your tests, you gain confidence that your docs match your product, that users experience consistent interactions with your product, and that your documentation remains accurate over time. This confidence extends to your entire organization. Support teams can confidently direct users to documentation. Sales teams can demo features knowing the docs will help users succeed later. Most importantly, you build and maintain user trust in your documentation, in your product, and ultimately in your company. This trust creates a foundation for lasting relationships with your users. So I encourage you to explore docs as tests for your own documentation. You can visit docsastests.com for strategy guides and implementation approaches with various tools. You can check out Doc Detective, which you saw the demo of, and I'm still actively developing and maintaining, or check out any other tool that piques your interest. Like I mentioned earlier, if you have the engineering chops for it, or you want to experiment and broaden your horizons, go to Playwright, go to Cypress, go to whatever other tool you want to experiment with. Get your docs tested. Get confidence in your docs. Seriously, connect with me on LinkedIn if you haven't already. If you have questions or want to discuss how this approach might work for your specific situation, remember, you don't have to do it all at once. Start small, prove the concept, and build from there. And you don't have to implement this alone. We're all in this together. We all want to improve our documentation. We all want to raise the bar, raise the standard of what our documentation can and should be for us, for our organizations, and for our users. But your journey toward more resilient documentation starts with a single test, and you're the one who has to do it. Thank you for your attention today. I'm happy to take any questions about the DocSys test strategy, implementation approaches, the Doc Detective tool, or anything else. If you are interested in ongoing discussion, please join our Discord community. We have an open Doc Detective Discord where we share ideas, troubleshoot challenges, collaborate on improving documentation testing. And remember, documentation testing isn't just about catching errors, it's about maintaining the connection between our docs and our products as they both evolve. That's what I got.
Yeah. Thank you so much, Manny. That was really nice, very detailed and very insightful. I definitely learned a lot about, docs as tests and, ensuring ways to, make sure that my documentation or documentation that we contribute to or write ourselves are up to date. Like Manny said, he's available to take any questions. Does anyone have any questions for Manny? You can just raise your hand, and if you're not, comfortable speaking, or you feel like you're in a noisy environment, you can always type it in the chat as well. But I feel like I have a question. Maybe
Sure.
we can get started with mine. So, there are certain documentations that have like a translation feature, maybe to be able to cater to different audiences across the world. So it could be like a documentation written in English and then it's translated to Spanish or French or something. Does the testing, like how does it account for maybe you're testing a documentation in a different language?
Sure.
Give it to
So
me.
the way that the demos that I showed the raw
Mhm.
markdown. But
Mhm.
really, that's not what we're publishing. Oftentimes, we are
Mhm.
publishing HTML or publishing in some other format. But there are a couple of ways you could go about doing it. If you're using something like Docusaurus, where the localized files are just other files that live elsewhere in the directory, you for your doc set, you can say, cool, forgive me, I'm going to continue using Doc Detective as my example, but you can say, Doc Detective, test this folder and with this configuration. And if you point toward the French folder, then your configuration could start with saying, cool, here's the base URL that we're going to use. So we're going to open up the French version of our product and we're going to sign in and then looking at all of the syntax for the files. Well, cool, everything's in French. But the syntax isn't in French. The syntax is still Markdown. And so it's still able to fetch all of the strings and content that it needs. And then when it loads up the user interface in French, it already has the French expectations from the content. So it doesn't care. It just checks to make sure that the documentation matches what it's seeing in the browser in this case.
Okay.
Um, but whether it's English, whether it's French, whether it is any other language, you can limit the scope of the files that you want to test at any given point in time. And you can provide other variables, like if, say, your user interface language is controllable by a URL parameter, then like it's uh, EN or FR, then you can load that as an environment variable and say, cool, when you run these tests, here's your language code. And then it can dynamically load that at runtime and execute accordingly. So you might say, cool, load this URL, but the URL parameter references an environment variable which pulls the language value. It at that point becomes implementation specific, but about how you would need to do this based on how your product handles localization. But it's entirely possible to say, yeah, run all my English tests. Yeah, run all my French tests. Run all my whatever tests.
Oh, nice. Thank you so much for that. Manny, let me see if there are any questions for you in the chat. You can also raise your hand to unmute if you have any questions as well. Or maybe you want him to maybe clarify something that he spoke about. You can also bring that up as well. Or if you're possibly hearing about doctors test for the first time and you have a couple of questions, there is some, points that you didn't get, you can also bring that up.
Yeah, and while people are thinking about it, one thing that I want
Okay.
to clarify is that I may have come up with a term, docs as tests,
Mm-hmm.
but people have been testing their docs in different ways for ages. And it's just, they didn't have a term for it, and there hasn't been consistent tooling for it. People oftentimes create a one-off tool for their specific organization, and it tests a limited aspect of their documentation. But bringing it together under a single, better understood term and practice, I feel is a big turning point for this. And for me, it's important to have these tools available to the least technical tech writer
Mm-hmm.
because having all these engineering tools is great. But if they're not usable, then they're useless. And
Exactly.
so that's why, like, when we looked at the standalone tests, you can do this stuff in Cypress. You can do this stuff in Playwright if you have the engineering background for it. But if we can lower that barrier of entry, if we can
Mm-hmm.
cut it down to just some YAML, eventually cut it down to not even needing that and being completely configurable by with our own GUI or that sort of thing,
Mm-hmm.
then it makes it easier for more and more people to test their documentation and have confidence in their content.
Yeah, that makes so much sense. Thank you so much, Mani. I think I saw that Zainab had her hand up earlier.
Yes. Hello, Manny. Zainab here. Sorry, I joined a bit late, but I really enjoyed the part of the session I joined. Thank you so much for joining us. And then apologies in advance in case I asked a question you might have covered earlier on.
It's all
So
good.
while you were talking, you mentioned something about like the levels, entry levels, for different tools that we have for docs as tests. You mentioned Doc Detective, intermediate, and all that. So I'm curious, like we have a lot of people coming into technical writing now, and some of the people on this call, they have some experience, but maybe not very much experience in using these tools. What are some core principles, not necessarily tools, that you would advise, beginner technical writers, to focus on as they are getting started and as they are growing into that intermediate and expert stage so that um, they can, very well capture these docs as tests and, be able to adapt these tools and maybe even, level that entry barrier.
Sure. So I'll reiterate the idea that you should choose the tool that suits your skills and requirements. The If you're doing API testing, you don't need a GUI tool. Congratulations, you get to skip that. If you're already familiar with Postman, awesome. Use Postman or use Bruno or use whatever alternative you so choose, especially if your team has already adopted a tool that you can use for this. And leverage your strengths. That makes it easier. Then you take the tools that you're already familiar with that can accomplish the task and figure out how to use them repeatedly without user intervention. So, for example, for Postman, you can create a Postman collection. And then you can set it up so that the Postman collection runs every day or runs via Newman, their CLI tool in GitHub Action, something along those lines. Congratulations. If you take what you've already got, sure, clean it up a little bit and then set up some reporting so that if things fail, you're notified. Congratulations. You're doing docs as tests and you've just got API workflow coverage handled. The hard part is if you update your documentation, you need to update your tests too. And so that's the difficulty with a lot of tools that weren't designed with documentation in mind. But all the same, a start is a start. There is no perfect tool. Start with what you can use. If you have to change at some point in the future, you can handle it then. The perfect is the enemy of the good.
That makes a lot of sense. Thank you so much. Because I think when people hear, doctors test, they think like, oh, it's something new, it's something entirely different, it has to be one cold tool and all that. But I mean, this just really helps testing documentation ideally should be something that every technical writer should be interested in right from the start. And being able to kind of like have these tools that helps to automate the process and ensure is really great. Thank you. That's answered my question.
Yeah, my pleasure. And reiterating the fact that we can't expect perfection. Well, first off, we shouldn't be expecting perfection from anything in life, let alone our work. And let's put this in a little bit in perspective. Engineers have been doing testing for literal decades on their code. Generally, the idea in engineering circles of having 100% test coverage is seen as nigh impossible. Some people do it, but engineers many times argue that they're spending too much time testing and not enough time developing. That's a philosophical debate. But the ideal, or at least a common high threshold of test coverage in engineering circles is like 80%. So many, I'd even wager most organizations don't test every piece of their code. So don't feel like you have to test every single little piece of your documentation unless you're really bored and have the time. You have to start somewhere. Start small, and as the practice, as you get more comfortable with it, and as it provides you more benefits, then you can expand as you have the opportunity to, as you are able to further prioritize it.
Yeah, I think that's actually a really important addition as well. I don't know, we still have a bit of time, about 2 minutes left, so Manny can still receive your questions. As he said earlier, you can also connect with him on LinkedIn, maybe if you have a question down the line, or if you try out Doc Detective, or you try to run some tests with your documentation, you can also reach out. But yeah, let's just see. Okay, one more
Also,
minute.
Doc Detective is open source, not only
Hmm.
the code, but also the docs. And as a tech writer by trade, I know the difficulties that go into contributing to open source, and I'm particularly understanding of them. So if anyone wants to dip their toes in open source, whether with technical writing or with engineering, you have a community you can lean on.
Okay, yeah, Zainab, you can go on.
Okay, so this is not directly a question, but I just wanted to let Manny know that one of our in-house technical writers, Jimmy, he's not on the call right now, has tried Doc Detective. We've been testing it out. We kind of like built like a new platform trying to document it, and we're testing documentation tools. And he tried Doc Detective out. We have a couple of questions. He's not on the call, so we might not have those questions now, but we'll reach out to you with them later, so that we can iron it out together.
Sounds fantastic.
All right.
Um, Anytime people want to reach out, I like to think I'm pretty friendly, so feel free,
All
whether
right.
that's on LinkedIn or on our Discord, wherever.
All right. Thank you. We sure will.
Okay, we've hit the 6:30 hour mark, our time. I don't know what time it is over there, but it's been an hour. So thank you so much, Manny, for coming on board, for speaking to us, for introducing us to the Docs as Test World, and just sharing from your knowledge with us. Basically, I've learned a lot, and I'm sure that everyone else has also learned a lot as well. Also make sure to check out, testing documentation and to take that small step and start, as you're encouraged. So yeah, thank you so much. I think we can wrap things up now. And thank you everyone for joining as well. And I'm definitely sure that you gained a lot from this session. I hope you all have You love it. Okay, you want to say something as well?
Oh, I was just going to say thank you for having me and thank you everyone for joining. It was a pleasure speaking with you
Yeah,
today.
amazing, actually. Thank you. Bye, everyone. Have an amazing rest of your day. Bye.
Thank you so much, Manny. Thank you, Toyibat. Bye.
My,
Thank
my
you,
pleasure.
Zainab.
Bye all.